Everyone. So we finished section 10.1 that was all about the correlation. Uh, we we learned how to find the correlation coefficient R, and also we also did the testing, hypothesis testing on correlation. Okay, so in this section, in section 10.2, we will learn about regression, and we will do some examples on this. Now, before I start, you might have completed your lab 10. So in lab 10, there was an assignment for you all to do. So it was all about finding the correlation coefficient, regression equation, and also the model, right? So what is this regression line? Now, you know that when you plot a QQ plot, quantile quantile plot, you will have, let's take this as data points. Okay, let me take this as some data points. Now this is a line which you see in your GMPQQ plot, right? Now this line is called as regression line. Why? Because this is the line which tells you how this will act as a reference line for your data points. So now you want your data points to be a straight line or follow this line, right? So when your data points does that, the meaning is the variable which you choose is a normally distributed, or it has a normal distribution, right? So that is how the regression line is useful for us. Now what do we do is, in this section, we will find the equation of that straight line. Now, when I mean by equation, when I want to plot a line like this, I must have, for example, let's say y equal to x. That means, okay, when x equal to 1, y is also 1. So I'll go like this, x is 1, y is 1, I get this point. Okay, in the same way, when you keep on plotting, you will meet a straight line. What if this is x square? When I do x square, you will get a curved line, or we call it as parabola, right? So all these shapes depends on the equation. Okay, so in this section, our work is to find this equation of a straight line. Okay, let's do that. Okay. Just to just a quick recap on what we did in section 10.1 and what we will be doing in 10.2. Okay, so remember 10.1 we started with correlation, and why is that? Because if you want to study a relationship between two variables, so what you do is you will collect the data, right, and then you construct a scatter plot. And why scatter plot? Because the purpose of the scatter plot is to determine the nature of the relationship. So we can easily find out whether it is linear, or it has a non-linear structure, or we say curve, or it has a zigzag relationship. All those kind of things we can determine using the scatter plot. Okay, and we also saw the positive linear relationship, negative linear relationship, etc. So once we draw the scatter plot, the next step are to compute the value of correlation coefficient R, and we then test the significance of the relationship. So if the value of correlation coefficient is significant, then the next step is to determine the equation of regression line. That is what we are going to do in this section. Now, why do we have to find this regression line? For example, let's say it enables the researcher to see the trend, the pattern, and make predictions on the basis of data. Okay, so it's more often used in a stock market. Okay. Now, how does the regression equation look? So when we are talking about a straight line, this is the standard equation for a straight line. Okay, usually we denote it in this way, mx plus b, where m stands for a slope. Okay, m means slope of the line. So when I say slope of the line, that means, let's say this is your straight line. Now the slope is increasing. Okay, so this is kind of a slope. Okay, when I keep like this is one of your straight line, then the slope is decreasing. Okay, the amount of curvature, or sorry, there is no curve, so the amount of slip in, we call that as a slope of a line. Okay, now what is x? So x is your x-axis in your scale. Then what is b? B is called as y-intercept. Okay, m is called as slope of the line and b is the y-intercept. So you will learn about this when we some examples. Now this is not needed. This is how we use in mathematics field. So this is like a general equation. Okay, now let's look at the equation given in our notes. Okay, so it says y cap equal to b naught plus b1x. Okay, now these are the definition for the notation. Okay, now as I said you here, b1 is called as slope. Okay, b1 is called as slope, b naught is called as y-intercept, and this y cap we call it as equation of the regression line. Okay, now just to give you look at this slope and y-intercept, let me draw a plot. Okay, so let's say we have a straight line here, we have a straight line here. Now I'm going to draw a line from here and here. Okay, now this is called as delta x and this is delta y. Now m is equal to rise by run. Okay, this is called as slope. Got it? Now when I see y-intercept, let's say this point at y-axis is 5. Okay, now we know that our equation line is y cap b naught plus b1x. Let's say this is the slope is, let's give some number here. Let's say the slope is 0.5 or 1 by 2. Okay, when I say delta x means the difference between this point and this point. When I say delta y, the difference between this point and the point here. Okay, this is delta x and this is delta y. When you divide the change in y with change in x, that will give you the slope of the line. Okay, so let's say in our example we have slope of the line as half. Let me write it here, y cap equal to b naught plus b1x. Now as I told you, b1 means the slope is 0.5 or 1 by 2. Let me take it as this. Okay, and I told you that b naught is y-intercept. Now when I mean, what do I mean by y-intercept? It is a simple term that means the value of on the y-axis from where the line is starting. Okay? So that is fine. This is how you write the equation of or regression equation. Okay. Now here x is called as explanatory variable, or we call that as independent variable also, and y cap is called as response variable or dependent variable because y cap is depending on x. Okay, x is not depending on y, but y cap is depending on x. So when I mean by depending, if I change the value of x here, 0, this will change, right? The value of y also changes. But when I change the value of y cap, x does not change. And that is why x is an independent variable and y cap is dependent variable. Okay, now to find the slope, as I said to you, it looks very simple here, delta y by delta x. But when we have x and y columns of data, this is how we find the slope, and this is how we find the y-intercept. So I know this is messy formula, but we can also find this using a calculator. Okay, so this is a small instructions on how you can find the regression equation. Okay, so let's get started with one example. So before we get into the example, let's see some of the uses of regression equation. Now, the main use of regression equation is to find the value of one variable using the value of another variable. Okay, how is that? Now let's say I have a linear relationship between height and weight of a person. Okay, now I have collected some data. Okay, I have collected some data, and this is a straight line and it follows a normal distribution. Everything is fine. Now, if I want to predict the weight of a person whose height is 73, okay, so suppose if I want to find the height of the weight of a person whose height is 73, then what can I do? Come back here, I will find the regression equation, and then using regression equation, I can predict the value of weight using the value of height. Okay, so that's the main use of regression equation. Now, where can we use this regression equation and where we cannot use this equation? Okay, so now when I say bad model, what do I mean by bad model? For example, if your correlation is not significant. Okay, so first step, what you do is plot a scatter plot matrix, scatter plot, and then you check whether the points are following the straight line or not, and then you find the R, correlation coefficient. So if the correlation is not significant, then you should not move forward because you will not have a regression equation for a variable whose correlation is not significant. Okay, so that's what this says, bad model. When you have a bad model, that means correlation is not significant, then you cannot use the regression equation to make predictions. But as an alternative, what you can do is you can simply consider the mean of that variable as the predicted value. Okay, now for example, not an example, but in your lab 10, you have three questions. 1A, you have 1A, 1B, and 1C. Now, just take a look at, pause the video and just go and take a look at 1B. Read the question completely. There it says if the correlation is not significant, you can consider the mean of systolic blood pressure as a predicted value, right? So that is what we are going to do in this section, right? So 1b was a bad model, and that is why we did not find the regression equation. Instead, we just considered the mean of that variable as a predicted value. Okay. Now, for example, IQ score versus height. Now, we all know that there is no such linear relationship which you can build using the height of the person and IQ score of the person. So just because the person is tall doesn't mean his IQ score is very good, right? So it can be vice versa. So that will be considered as a bad model. Then what could be the good model? So as you know, first we construct a scatter plot, and if that tells you it will fit the points well, then we call that as a good model, and also you will have a significant correlation, and hence you can build up a regression equation to make predictions. Okay, so this is good model. Now when it comes to correlation, what does this have, what does this contribute to make predictions? Now, using regression equations for prediction, if you only have a linear correlation, then only you can move forward. Okay. Now, what about scope? When I say scope, that means let's say we are in 1980. So you're surveying in 1980 and you make predictions on 2022. That's way too far. That's out of scope, right? So you can make predictions maybe for 1990 or maybe for 2000. That's good. But when you want to make a prediction for more than 30 years, that's clearly out of scope, right? Let's say your survey says in 1970. Let's say we are in 1970, and let's say you made a survey on oil in the US, and you concluded that by the end of 2000, or maybe by the end of 2010, we will not have oil reserves at that time. But fortunately, we still have, right? So the predictions which you made was completely wrong because that was out of scope. Okay, so that's the 4 points of this one, regression equation. Okay. Okay, so next is how to solve the problems and the steps for that. Now, what we do is we do hypothesis testing. Okay, so step one is hypothesis test, and step two is making a prediction. That's what we need. Now, before that, how can we predict a values for y? Now, all you have to do first thing is to find out whether it is a good model or not. So when I say good model, what are we supposed to check? First is you need to check whether the line fits the points well. Best line of fit. Okay. Second thing, does R indicate the linear correlation between two variables? Third, is it out of scope or beyond the scope? Now, if not, if it is not out of scope and R as a linear correlation and you have a best line of it, then you will come here and say yes, the regression equation is a good model. So what are we supposed to do? We are going to substitute the given value in this equation and find y cap. And now let's say it is not a good model. So you will come here, you will say no, the regression equation is not a good model. So what do? Regardless of the value given in your problem, you're not going to substitute anything here. What are you supposed to do is you will consider the best value of y as the predicted value. Now when I say the best value, that means the mean of the y will act as your y cap. Okay, or y bar. Okay, so we have example one here, and we will see how to do this. Okay. Now, pause the video and read the question for a minute. Okay. Now, what are we supposed to find? You're supposed to find the best value of y cap given x. For this x equal to 7, I want to know what is y cap. So now I need to know the relationship between y cap and x. So how can I find? You don't have to find. That is given. And where can I use that? Here. So this is called as regression equation. I will just write in a short form. This is called as a regression equation, that is y cap 8 equal to 8.24 minus 0.358 into x. Okay. Now all you have to do is just plug in x equal to 7 here and find y cap. But why do you think the entire question is given like this? Why do you need all this? That is because the first step is not just to plug in and find y cap. That would be entirely wrong. So first step, all you have to do is this. Check whether your equation is a good model. Now, first thing is you have to check whether it is a good model. So I'm going to delete the step. So first step 1 is to check the model, whether it is good or bad. Now, how can I check? If your p-value is less than alpha, then we'll say yes, it is a good model. Okay. Now, just as a procedure, we will write the null and alternative hypothesis. H not equal to rho equal to 0 because it is a correlation, so we denote that by rho. This is called as RHO rho. And H1 rho is not equal to 0. Okay. Now, so initial conclusion is what you make. P-value is less than alpha because it's given here. P-value is what? 0.031. Significance level is 0.10. Since it is less than, I say yes, it is a good model. Okay. So since it is a good model, what we do is second step, make a prediction using y cap, which is 8.24 minus 0.358 into x. Okay, all you have to do is plug in the given x and find y. So y cap equal to 8.24 minus 0.358 into 7, and that gives you the final answer, 5.734. This is your final answer. Okay. Okay, next example. Now for the following example, complete the following. For first is we need to find the hypothesis test. We need to check the linear correlation between two variables, and we need to find the regression equation, and then we need to find the value of y. So in example 1, everything was given. All we had to do was find y cap, but this time the data is given. Data is given. You have to perform the hypothesis test to check whether it is a good model or not. Okay, so that's the first thing we do, and then we find the regression equation using the given data, and then we find y cap. Okay. Okay. Step 1 is to perform the hypothesis test. So I will write the null and alternative hypothesis. H1 not equal to 0. Okay. And next is to find the p-value, because we need to compare the p-value with alpha and then make conclusions, right? Now here, if alpha is not given, just for this example, take it as 0.05, and let's find out p-value. Now you will find p-value like you did in section 10.1. So how can we do that? All you have to do is find the critical value R, because we can also make comparison with critical value and the statistic and make conclusions, or even we can find the p-value and then make conclusion. That's also possible. Now, how can you find the R using critical value? I told you that we are supposed to use the table, right? So let me open the table. Okay, now scroll down and go for table number A6, critical value, finding the correlation coefficient R. Okay, so all you want is to check what is n and what is alpha, because you have two things here. Now I know that alpha is 0.05, alpha is 0.05, and n equal to 5, n equal to 5. 1, 2, 3, 4, 5, or n is equal to 5. Okay, so I know that n is 5 and alpha is 0.05, so my value is this 0.878. 0.878. Okay, so in the same way you will find the test statistic R. Okay, so we found the value of R using the table, and next is we need to find R using the statistic, and we use calculator for this. Okay, you have to follow the steps which I do now. So to find the value of R, go to second and then go to catalog, or you can just press 0 on your keyboard, 0 on your calculator, and if you scroll down you will get diagnostic on. Okay, keep scrolling and you have to get diagnostic on. Here it is. Okay, so once you do this you have to enter twice, 1, 2, twice. Okay, remember, enter twice. So when you get this done you have to do the following step. Okay, and next step is go to stat edit, because we need to enter the tables here. Now in L1 you are going to enter the values which are there in Shoeprint. Okay, so it is 29.7, again 29.7, 31.4, 31.8, 27.6. Okay, and next is L2, 175.3, 177.8, 185.4, 175.3, 172.7. Okay, and after this, once you enter L1 and L2, go back to stat and then test, stat, test, and search for LINRAG t-test. Linear regression t-test, LINRAG t-test. Okay, here it is. Option so this might be different in your calculator because mine is TI-83 plus. So you have to choose LINRAG t test. Okay, so enter. Now you have L1 there, L2 there, and all you have to do is come down and click on enter. Okay, so this will give you the R value as well as P. Okay, so let's come down here. I need R. So we have R here as 0.591. Okay, you have to click on this down arrow to find the R value. Okay, click on the down arrow and you get R as 0.59, as well as you also have P value here, which is 0.29. Okay, so if you do this step, you will get both R and P. Keep this in mind, you will get both R and P. So R value is 0.591. I'll just round it off and I will write it as 0.591. Okay, and you also get a P value. So in your calculator, your P value is go up. So it is 0.2936. So 0.294. I'll just write it as 0.1. Okay. So once you get this, you can either compare the critical value with the statistic or you can compare P value with alpha. So we have both and let's do both comparison. Okay. So critical value R is greater than the statistic R, right? Because this is 0.878 and this is 0.591. And here you have P value that is greater than alpha, and P value is 0.294 and alpha we took it as 0.05, right? So when we have P value greater than alpha, your initial conclusion is what? Fail to reject H naught. Okay, so if you have failed to reject H naught as your initial conclusion, that means there is no linear correlation. That means what? If you do not have a correlation, you cannot build a regression equation, right? So we are not going to proceed to the next step. So what we do is, second step, we do a prediction value. So when you do not have the correlation, that means you are not going to build the regression equation, correct? So there is no regression equation. Predict y cap for x equal to 29, that's the problem. But this is not a good model. So we will not have any regression equation for this model. Okay, so what do? We do So we take mean of y variable and call that as y cap. Got it? So now go back to the column here. Now take a mean of this. That means you're going to add all these values and divide by number of values present there, which is 5, right? So if you do that, you can do that in your calculator. Y cap will be equal to 175.3. I am adding all the values present in y, which is height 175.3. So if you do this, so if we call y cap as y bar now, because it's a mean, which is equal to, this is your answer. Okay, as you see, we are not using x equal to 29 anywhere. Okay, because it's not a good model, so we are not going to build the regression equation. Okay, so now let us take a look at the example 3. You can do the same thing. Step 1. So now I'll just give you a tip. Okay, so since you know how to do, we did 2 examples. Pause the video and try to get the answer. Okay, try for the answer so that you will know where you are going wrong or where you pause, and then just resume the video and then you will get your answer. Okay, step 1, hypothesis testing. Okay, we need to check whether it is a good model or not, and then we can use the equation. Okay, so for that we will write h naught. So this alternative and null hypothesis will be written in this way for all the problems. Okay, and then you find a critical value. So critical value is 0.312. How? You go back to the table here. Now n is equal to how much? 40, right? And alpha is not given. Okay, take alpha equal to 0.05. So go back to the table. Alpha is 0.05 and is equal to 40. Scroll down, n is 40 here, alpha is here. So this is your critical value r, which is 0.312. Okay, and in the same way you calculate the statistic r. Follow the instructions, above instructions in your calculator. I'm not showing this because if I just show you how to do, if I walk you through that, all you do is just follow whatever I do. But when you actually do on your own, you will know where you get stuck. Okay, and that's the main reason I'm not going in detail with the step. So again, follow the instructions. Mentioned above in your calculator. Okay, and then you find the statistic r. So you have to get 0.813, and then you will get p-value in the same step. Okay, So you will have p-value as 0. Yeah. And now you can compare critical value, or else you can also compare p-value. So I'm going to compare p-value with alpha. Since this is 0, then this has to be less than alpha. So your conclusion, initial conclusion is reject H naught. If you are rejecting H naught, that means there is a linear correlation, and hence it is a good model. If it is a good model, that means you will have a regression equation. Okay. So now step 2, we don't have to find the regression equation for this problem because it's already given here. So I'm just going to use the same thing, y cap. This equation is in the problem. Okay, 3.22 into x. Fine. Then what is x? X is 29 centimeter. They want us to take x as 29 centimeter. Now, actually, p-value and r both are given. You don't have to calculate, but you can try so that you will get a practice. Okay, so y cap will be equal to 80.9 plus 3.22 into 29, because I write this 3 dot and the meaning is because. Okay, so x equal to 29, it's given, right? Okay, so when you do this in your calculator, you have to get answer as 174.28 centimeter. Yeah, that's your answer. Okay, so this will complete section 10.2, regression.